All right, today we're going to look at some differentiation rules. So rules on taking the derivative, including the power rule and then derivatives of sine and cosine. So let's first look here at the line y equals -1. The function f of x equals -1. That is a horizontal line. So the derivative of that, the slope of that, is 0. The slope of a horizontal line is 0. All right, what about the function y equals 2? F of x equals 2. The slope of that is 0. So the derivative of that is 0. Now let's look at the line y equals 1. F of x equals 1. The slope of that is 0. And so the derivative is 0. Derivative is the slope. So what conclusion can we make here? The derivative of a constant, is 0. Oh, I didn't even spell that right. Hold on. The derivative of a constant is 0. So what's some good notation for that? We're going to say the derivative with respect to x of the constant c is 0. You'll get used to that notation. All right, so some examples. If f of x equals 2/3, f prime of x, which means the derivative, is 0. Number 2, if y equals -10, y prime, which means the derivative, equals 0. If y equals 3.14, dy dx, which means the derivative, is 0. So pay attention to all that different notation. F prime of x is the same as y prime, is the same as dy dx. All right, so what about all these functions? All these functions are lines. So the line y equals 1/2 x. The slope of that is 1/2. So y equals 1/2 is the slope of that line. What if we have the line y equals 1/2 x minus 3? The slope of that, the derivative of that, still 1/2. How about the line y equals 1/2 x plus 2? What if we shift it up 2? Slope of that, still 1/2. So what can we conclude there? The derivative of a line is a constant because it is the slope. So the derivative of a line is a constant. It is the slope of the line is the derivative because slope means derivative. So we can write that as the derivative with respect to x of a function in the form mx plus b will always be m. So here's our examples. If f of x equals 3x minus 1, find f prime of x. That's just going to be 3. The slope. If y equals -1/3 x plus 4, y prime, -1/3, the slope. And if y equals 7/10 x, dy dx, 7/10, the slope. Another thing to note here is that what's the derivative of the b? That's what we did in the last side. The derivative of that is 0. So you can see why that is not part of the derivative. All right, let's look at each of these. So on this first one, we have if the original function, if f of x is a line, its derivative is a constant. If f of x is a parabola, a quadratic, its derivative is a line. And if f of x is a cubic, its derivative is a quadratic. And that's the same for the second column of things. It's just slightly different functions. So what do you think if we have a function, if f of x is quartic, meaning a degree of 4, then f prime of x will be, you guessed it, cubic. All right, so how can we write that out? We're going to say that if the function is linear, its derivative is a constant. If a function is quadratic, its derivative is linear. If a function is cubic, its derivative is quadratic. And if a function is quartic, its derivative is cubic. And why does that work? If you think about the derivative comes from f of x minus f of a over x minus a. These are just constants. So f of x divided by x means you're taking 1 less power. You are dividing by x, so it'll drop you down 1 power. Okay, let's look at this thing called the power rule. The power rule says that the derivative with respect to x of x to some power, you move the power out front and then drop it down by 1. Okay, so number 1, f of x equals x to the 4th. So f prime of x is you move the power out front, so 4 out front, x to the, drop the power down by 1/3, 4x to the 3rd. All right, number 2, derivative of x, or derivative with respect to x, d dx of x to the 3rd means take the derivative of that. Okay, so that's like telling you what to do. So the derivative of that, move the power out front, that's 3. X, drop it down by 1, squared. All right, number 3, y equals x to the negative 3. So we can call its derivative y prime or dy dx. Both of those are good. Let's call this one y prime. Move the power out front, negative 3. X to the, drop it down by 1. So negative 3, 1 smaller than that is negative 4. The negatives sometimes get tricky and we go the wrong direction. So negative 4. So that's the power rule, but of course it's never going to be that easy. They're never just by themselves like that. So let's look at some other rules here. So we said that the constant rule, the derivative of a constant is 0. So if y equals 4, y prime is 0. Then we have the power rule. And then we got a tricky number 2, y equals square root of x. That doesn't look like a power, so we actually need to write it as a power. Y equals 1/2 x. So we need to write it, or y equals x to the 1/2. We need to write it as a power so we can use the power rule. So we're going to say the derivative of that, dy dx, is move the power out front, 1/2. X to the, drop it down by 1 if you need to write off to the side. 1 minus 1/2, or sorry, 1/2, drop it down by 1. 1/2 minus 1 is negative 1/2. And number 3, if f of x is x to the negative 6, then f prime of x, move the power out front, negative 6x to the, drop it down by 1, negative 7. All right, the constant multiple rule says, what if there's a constant out front? Well, all you do is continue to take the derivative and leave that constant out front. So f prime of x, we're going to leave the 3 out front, and then we're going to do 7, move the power out front, x, drop the power down by 1 to the 6th. Except you're never going to write it like that because we're going to get really fast and good at these. We're going to write this as 21 x to the 6. So when you move the power out front, you're going to multiply them. All right, so number 5, that is not ready for power rule. We need to write it as a power. So that is 6x to the 1/3. And so dy dx, the derivative of that, we're going to move 1/3 out front and multiply it by 6. So 6 times 1/3 is 6/3, or cross cancel, and you get 2. So 2x to the 1/3, drop it down by 1. 1/3 minus 1, or 3/3, is negative 2/3. And then addition and subtraction means you just add and subtract them separately. So f prime of x here, we're just going to take the individual derivatives and add them separately. So we're going to move the 4 out front and multiply. So that's 12x to the, drop the power down by 1/3, minus 6x squared, plus the derivative of x, that's a 1 out front, right? So that is just 1. And then the derivative of 7 minus 7 is 0. So that's how you that's putting all of them together. All right. So let's do some tricky ones. But the only thing we know is the power rule. So we need to write this as a power. So that's the key here, is writing these all as a power. So let's write this as 4/5 t squared. Let's write it as a power. So the derivative, f prime of t, is move that 2 out front. 4/5 times 2, that's 8/5. T, drop the power down by 1, that's just 1, so 8/5 t. All right, number 9, need to write that as a power. That's x to the negative 2. Remember, a negative exponent flips it to the bottom. So that's x to the negative 2nd. So y prime, the derivative of that, move the power out front, negative 2. X to the, drop the power down by 1, negative 3. All right, number 10 looks like something totally different, but it's not, because you are dividing by a monomial, a single term. Monomial is a single term, which means you can just divide each of them by x. Okay, so if we divide each of them by x, we can rewrite this, f of x, we're not taking the derivative, we're rewriting it. X to the 4th divided by x is x to the 3rd, minus 3x squared divided by x is x, plus 2 divided by x, you could write as 2 over x, which if you look back to how we did number 9, we're actually going to rewrite this again. This is x to the 3rd minus 3x plus 2x to the negative 1. So we were able to rewrite number 10 as powers, and now we can take the derivative. F prime of x is 3x squared minus 3 minus 2x to the negative 2. And number 11, again, we need to rewrite those as powers. So we're going to rewrite f of x as 6x, and we're squaring and then cube rooting. So that's a fraction exponent. That's to the 2/3 minus 4x to the negative 2. So the derivative, f prime of x, we're going to do power rule. So 2/3 times 6, if you need to do that off to the side, go ahead. 6 times 2/3, we're going to cross cancel those, and we get 4. So 4x to the, drop the power down by 1. 2/3 minus 1, or 2/3 minus 3/3 is negative 1/3. And then we're going to do power rule again. We're going to multiply by -2. That's going to be a +8. X to the, drop the power down by 1, -3. So there you have your power rule.